now I'm going to go to Mark Sokol, who is going to do lab updates. If there he is, Mark. She's all yours, sir.
One second. It sounds like we have a little reverb. Oh, it's from that. Okay, that should be a little bit better. So basically, we have continued work on this gyroscope contraption over here. Was inspired by Mike Gamble and his work with gyroscopes at Boeing. Tom Butler over here has assisted with both the build design and the software. So we've come to a point where it's pretty much complete. The software can be tweaked a little bit more, but we set it up on a bed of ping pong balls, so it's pretty resistance free. And the force measurements you're seeing are over there are actually two axes, the red being lateral left and right. So we don't expect much movement on the left and right, but up and down, which is the blue measurement, should be showing some either positive or negative force. That's where I'm pushing it. Basically, these force sensors are on one side, and on the other side, there's a constant spring action. So although the object's not going to be moving, we are going to see slight, changes in weight that are commensurate with the amount of thrust being produced. We did run this on a test stand earlier in the week. I posted a video on YouTube. It was moving around, following the direction as expected. Although people did note that, the surface needs to be perfectly level, which is why we're actually working right now on getting a section of the lab perfectly flat level. So we'll be able to see whether, for future tests, we'll just be able to set it down on this section that we know is perfectly level and, use the same ping pong test to try it out. So without further ado, we're going to power it up. With these two switches.
Should we have to hold this down?
I think it'll be fine. So programmed in a small period of no movement. I'm just going to help it start up. This was to give the motor some time to there they're going. So the motors right now are spinning up. We're going to use the sleeve of your jacket. Yeah. Start collecting the data. So there you have it. There's the data is right over here on the top left. We are seeing larger spikes on the blue. The blue, of course, is the I believe, yeah, the blue is the lateral force. So it'll be up and down. So that's the direction we are expecting force. And we see there is more. It's all shifting towards the negative side, and this was zeroed out before the test. So I do think there was some results over here. As expected, it is sort of a pulsing effect. Let me see if I can zoom in on this.
Well, so Mark, my question is, are you going to put me under NDA for this? Yeah, sorry. It looked like the ping pong balls might have been getting held up in the grooves on that box.
My dog
Well,
hated it.
the box is it's made out of this really smooth material on the floor, on the base of it. I don't think
okay.
they're held up. They're not touching each other. They're like placed in there sparingly. I'm not too worried about the friction on the base. And we can see from the data, I would just ignore the red because we're not really expecting any effect on the red side. It's really the blue that we're looking at in terms of force meter number 2 it is, I think. Yeah, force meter number 2. That's the one that matters over here. And you can see the reverse spikes are much less than these long pulse, pulses of inertial movement that are going up to like 6 newtons of force. It will be very interesting to see how this works out once we get our level floor set. We have a team over here still working on that. So it might be sometime tomorrow when we get that done. But the results so far are looking pretty promising. The goal is to get a device like this fine-tuned using a setup like the rig we have over here. We're going to be playing around with this with various settings in the software, different pulse lengths for the forward and return. This is sort of like swimming gyroscopes through space. And we'll compare notes with different setups. The goal is to get it to go up a couple degree incline, and if we can do that, and present that in Albuquerque at Tesla Tech, that would be quite an achievement. That would be pretty cool. But so far things are looking pretty positive for this experiment. We shifted away a little bit from the Alzaphon experiments right now because this was so close to being done. So I just jumped in, gave Tom a hand, and we popped it out in the last couple of weeks. The Alzaphon experiment still set up right now. I see David Alzaphon is here in the crowd. He came to see what was going on over here. So we do have your experiment still set up. We saw some pretty weak results, nothing close to 80% weight loss. Strongest results were with very thin film materials. And I intend on diving down that path a little bit more. I think George Hathaway mentioned as well that the skin depth of X-band radiation is very shallow in any material like aluminum. So you really need very thin layers in order to see any effect. So we're looking into a vapor deposition system that will allow us to try very thin layers of various materials. You can layer on top of each other or capacitor formations. And with that, we'll just put that in the EPR machine or in the dynamic nuclear orientation rig and see what happens with that. David's asking if we're able to get into the 3.3 gigahertz range. Yes, we are. We have 200 watt amplifiers that go all the way from 400 megahertz to 12,000 megahertz, 12 gigahertz. We have so 3.3. I think that's the S band. George Hathaway was thinking of doing it in the S band as well. Be very large waveguides if you want to do a waveguide version of that. Which direction was the rotor spinning? I think Harold put that in the chat. For the gyroscopes, they're spinning in opposite directions. So their outsides are spinning downward like that. But if you were to twist these forward, they would both be moving like the tires of a car to move forward. So that is all, folks, for now. Hope to have a bigger update for you guys in 2 weeks.